What are my possibilities? I can have resolution 1 and 1. I can have 1 and 2. I can have 2 and 1, and I can have 2 and 2. Right? Half of these give a crossover, half don't. If they're different, they give a crossover. Now, if we did both of them by 2, actually, you would, in a sense, you could almost think of it as a double crossover if you could actually kind of see what was going on here, if you were looking at it with respect to B. Okay? So let me do a situation here where if we did number 2 at both positions, okay, and I had no heteroduplex, or at least the repair ended up this way. Now when we measure out, follow out our alleles, what we'll actually see is big A, little b, big E, right? A, this resolution 2 brings us down here, and resolution 2 again brings us up top, because then this joins up here, and this joins down here. So B, D, and A, B, E. This is not a crossover with respect to A and D. A and D are on the same chromosomes. But if the question was, is this a crossover with respect to B, then there is a crossover of A with respect to B and B with respect to D. So it's actually a double crossover if we're looking at allele B. So kind of determining what's a crossover and what's not is a relative thing in terms of what you're actually focused on. Okay? But usually we're talking about distal markers, and at least with respect to distal markers, most of this paternal chromosome is still attached to most of this paternal chromosome, and most of this maternal to this maternal. This part is tiny compared to a whole chromosome. Okay? This section that involves the homologous recombination and strand exchanges and so forth is very, very small with respect to a whole chromosome. Okay, let me just, one more thing on numbers, okay? All right, so, like I just showed you here, normally you have a pair of homologous chromosomes. You undergo DNA replication and you get sister chromatids. And if it's a normal mitotic cell and a break occurs, usually it's going to use a sister chromatid to repair that break. And then, even if there is some kind of exchange of genetic information, which is what's involved in the strand exchanges, they're genetically identical. So you would never even know that that event occurred. Okay? But if the break occurs before you have sister chromatids, so if this is a G1 phase cell that hasn't entered S phase yet, and maybe it gets hit with X-rays, and you get a break on the chromosome, now when you get your exchange, your repair, the whole thing we just went through, and if you should happen then to end up with heteroduplex formation here, and then if repair of the heteroduplex results in the little b, the big B allele is being lost, and little b is gained, now you've had a gene conversion. Okay? And that's a loss of heterozygosity right there. First I had a big B and a little b, and now I don't have it. It's homozygous little b. So that was loss of heterozygosity through a gene conversion event, because I had 1 to 1, now I have 2 to 0. Any questions? Okay.